All right, so we're plugging in -2, -1, 0, 1, and 2 for everything but the roots, the square roots and the cube roots. If you plug -2 into linear, you get the same thing out. So our linear parent function is just a diagonal line going up forever. And you could choose other points. I just want to make sure you use some negatives and some positives so you know what both sides of the graph are using. What is the domain? Negative infinity, positive infinity, range? Same. Intercept meaning like x-intercept, y-intercept. Where does it cross the x-axis and y-axis? The point 0, 0. With increasing, decreasing, and constant, you're trying to figure out what interval of the domain is increasing. So where is this graph increasing? Huh? Both ways. Always. It's always increasing. So from left to right, you always read a graph from left to right. It is always increasing. So negative infinity, positive infinity. To be even or odd, I'm sorry. What was somebody saying? No. To be even or odd. To be even, you plug negative x into your equation. And if you get out the exact same original equation, then it's even. To be odd, if you plug a negative x into your equation and you get out the exact negative of the original equation, then it's odd. So even and odd, it took about like 4 of these parent functions for my last class to catch on. So if I plug negative x into my original equation, so now y equals negative x, do I get the exact same original equation back or the negative of it? The negative of it. The negative of the equation, so it's odd. If you don't get that, that's okay. We got a lot more to explain. The first two aren't really great examples of even and odd. This is symmetric to x-axis, y-axis, origin, or nothing. Is it symmetric to the x-axis?
No.
Y-axis?
No.
No. Origin, to be symmetric about the origin, it's like a twofold. You fold it over the x-axis and then over the y-axis. So I'll fold this top right quadrant down over the x-axis and then over the y-axis. So since it lines up, it is symmetric about the origin. So that's a twofold. We're going to do more of that. Constant, y equals a number, any number. Today we just chose it was -1. It could have been, my last class chose it was -4. So any number. But if I plug in -2, I'm going to get out -1. If I plug in -1, I'm going to get out -1. If I plug in 0, I'm going to get out -1. It's constant. Y equals -1. No matter what number I choose, I can plug in 100 and I'll still get out -1. So we have a horizontal line. Is it a function? Yeah. These are called parent functions, which is why we don't have a vertical line on this paper, because a vertical line wouldn't be a function. Yep, these are all functions. Domain? Infinity, positive infinity. Range? -1. In brackets. Just -1. Where do you cross the y-axis? 0. -1. I'm going to put C because no matter if this was like 2, then it'd be 2. If it was 5, then it'd be 5. So -1's not wrong for this specific graph, but if you look back on it, I want you to know it's whatever number your equation is. Increasing, decreasing, and then constant. Where is this graph constant? Everywhere. Domain. Think of your x values. Where is this graph constant? It's never increasing. It's never decreasing. It's always staying constant. If you plug in negative x to the x of this equation, which there isn't one, you're going to get the exact same equation out. So it's even. Symmetric to the x-axis, y-axis, or origin. Y-axis. Because you want to fold it in half over the y-axis. So if I fold this graph over the y-axis, this part's going to fit on top of that part. Absolute value -2. Absolute value -1. What about the absolute value of 1? 1. I've seen somebody think that it makes absolute values make negative, positive, and positive negatives. So don't think that. What shape is it when you graph it? A V. Later on, when you have to remember that, think absolute value. Value starts with a V. This graph looks like a V. And it goes on forever. Oh, man. Hey, not bad. Domain? Pretty consistent, right? Infinity, pounds, penny. Range, 0 to infinity. Intercept, 0, 0. Where is this graph increasing? Yeah, nice. From 0 to infinity. You always read a graph from left to right. So starting on the left, coming to my right, it's decreasing until I get to 0, and then it starts increasing. But you can't increase or decrease at a point. So when you write increasing or decreasing, it's always parentheses. So 0 to infinity. It's not a bracket because you can't increase at a point. You have to be comparing 2 points to increase. Decreasing? Infinity is 0. So if I plug in negative x into this equation, it's going to stay positive x. So is it even or odd? If you get the exact same equation back as the original, it's even. If you get the huh? I thought that's what we all said. I thought I heard odd. My bad. And symmetric about y-axis. Any of this new? All of it's new? Except for the graphing, domain, and quadratic. This is where I see a lot of people mess up. Half of us messed up in this class. -2 squared. +4. But if you put it in as -2 squared, order of operations is going to square this number before it multiplies to -1 in front of it. So make sure if you plug it in, parentheses. Or just know a negative times a negative is a +4. So be careful. 4, 1, 0, 1, 4. If I plug in 3, I get 9. Missed it. Try your hardest not to make this look like a V, because this isn't a V. It's a U. Or the fancy word for it. What's the fancy word for it? Parabola. U-shaped graph is a parabola. Spelled parabola. And how does it compare all these characteristics? How does it compare to absolute value? Domain? What's our domain? Range. 0, 0. 0 to infinity. The infinity is 0. Even. What's the magic about the
squares? It's gonna make it even.
if I plug in a negative x and I square it, it's going to make it a positive. So it's the same as the original. So it's even. So actually all that information is the same for absolute value and quadratic. We just copied it over again. On the back. Slow me down if I go too quick. On the back, I told you to skip the roots. So we'll do cubic. Negative 2 cubed. Almost. Negative 8. Take one out.
Is that raw weight?
Take one out. You should always be able to hear me. Daniel, take one out.
What?
Take out a headphone.
Raw weight.
My boy Rod Wave. Don't play around with Rod Wave now.
There's a bat.
Listen to the tombstone, brother.
That's cubic.
What you know about Rod Wave?
Domain?
Finally.
Negative infinity, positive infinity.
Finally.
Range. Negative infinity, positive infinity. Down forever, up forever. Intercept. 0, 0. Increasing.
She's a runner. She's a track star. Waukesha.
0 to infinity is increasing. And so the whole thing. It's always increasing. Always increasing. Yeah. Even or odd? Odd. Odd. If I plug in a negative x to this equation and cube it, negative times negative times a negative is still a negative. So it is the complete negation of the cubic function. So that's what makes it odd. You get the same equation back, it's even. If you get the opposite equation back, it's odd.
Tastes like candy.
This is symmetric to
No,
If I reflect it over the x, then it's going to be up here. If I reflect it over the y, then it'd be, wait, that is reflected over the y. I said that wrong. If it reflects over the y, it'd be over there. If I reflect it over the x, it'd come down here. And if I reflect it over both, then this piece would lay on that piece. So it's symmetric about the origin. Totally thought you said I spelled it wrong for a second. Or like meant I spelled it wrong, which is possible. Totally possible. All right, now let's go back to the ones we skipped. Yes. Square root. What numbers do you know the square root of? 9. What's the square root of 9? 3. 4. 2. 1. 1. Huh? 0.
Can I go fill up my water?
0.
Yeah.
16. And now we're off the graph. So why didn't I use -2? Because I didn't want you to use -2, -1, 0, 1, and 2. Why would that be? The square root of a -2 is non-real. It's imaginary. So you can't graph imaginary numbers. But if you did do the square root of 2, you could do this, 2, 1.41. You're more than welcome to graph that. It's just a decimal. So I could do 2, 1.4, but I don't know why you'd want to graph decimals when you know nice numbers. $16.4 was 1, 2, so you should know where it's headed. I missed that. 9, 4. Oh, I'm off 1. Try that again. Curvy. No, 9, 3. What am I saying? 4, 4. There we go. All right. Domain. 0 to infinity. Range. Same thing. Intercept. 0, 0. For the parent function, yes. When we start moving it up, down, left, and right, it's going to change. That's what you have to look forward next week to. Increasing. 0 to infinity, not including 0, because you can't be increasing at a point. Last one. Cube root. Cube root and cubic are inverses of each other. They undo each other. So if I put in -2 for cubic, I get out -8. So for cube root, if I put in -8, I get out -2. So the easiest way to do cube root is to look at cubic and just switch them. That's the easiest way to do cube root. Just know they undo each other.
Fine.
Because a lot of people don't know they're perfect cubes. Perfect squares, you guys know. Perfect cubes, not so much.
Perfect cube is 3, right? Or 9.
That's the perfect square.
Oh.
Perfect cube
27?
is 0, 1, 8, 27, 64. Might not be 64. I don't know. What's 4 times 4 times 4?
4 times 4 is 16 times 4 is 64.
Is it?
Yep. I mean, just call me daddy already. I mean, I'm the greatest.
Domain. Name infinity positivity. Going left forever. Going right forever. Going down forever. Going up forever. Where is this graph decreasing? It's actually a typo. It never decreases. It's always increasing. I liked that it was a typo though, so I didn't change it. Because a lot of people want to say it's decreasing just because it's there. Say it one more time.
But it's a lot.
I know. Trick question. Is it even or odd? Odd. If I plug in a negative x, the cube root of a negative number is a negative cube root. So it is the complete opposite. So it's odd. And this is symmetric to the origin. Another way to help you with odd and even, if it's odd, it's symmetric to the origin. If it's even, it's symmetric to the y-axis. Never symmetric to x, because then it wouldn't be a function.
Yeah.
So if it's even, it's symmetric to the origin. No, I said that wrong. Hold on.
I gotta show you.
If it's odd, it's symmetric to the origin.
It's the response. It's the response.
If it's even, it's symmetric to the y-axis.
You know why that is?
If that helps you remember it.
There we go.
Now I remember it is OO, odd origin. Odd origin. OO, odd origin.